All right, today's lesson is 4.1. Go ahead and do your warm-up, and then come on back and I'll show you the formulas and we'll talk about the answers. So hopefully you have all these formulas written down in your notes someplace. I think we talked about in class today maybe making a formula sheet so that you guys would have them easily accessible at all times. All right, so midpoint is you add I'm doing the slope first. You subtract the y's and then subtract the x's. So I subtract my y's, that's these two guys, so that's going to be 5 minus -3. And then my x's are going to be 2 minus -1. That's going to give me these double negatives are going to become positives. So that's going to be 8/3. Slope of 8/3. Oops. There we go. Okay, sketch a graph of the equation. So you need that in the form of y equals mx plus b. So what you need to do is solve for y. All right, so I need to get rid of that 3x because I'm trying to isolate this y term right here. So when I subtract 3x from both sides, that's going to give me -2y equals -3x plus 12. And then I'm going to divide everything by -2. So that will give me y equals +3/2x minus 6. So a really basic rough sketch of that would be something like this. 1, 2, 3, 4, 5, 6, something down here, and then up 1, 2, 3 over 2, so 1, 2, 3, so over here someplace. Okay, so just a basic rough sketch is all you need for that. Midpoint is add the x's and divide by 2, then add the y's by 2. So if I add the two x's, 6 plus 6 gives me 12. Divided by 2 is 6. And then 7 plus -9. 7 plus -9 is -2 divided by 2 is going to give me -1. So the midpoint of that segment is x is 6, y is -1. Distance formula, plug your values in. You should have come up with 16. All right, reminder of your commitments that you made yesterday. Make sure you write them in your notebook so that you can easily see them for the rest of the week. Also, 8th hour change, I'll be in the 1101 lab right down the hall. I have an algebra class in there, so I need, at the end of the day, so I just need to stay in there. The Chromebooks are in there anyway, so it works out for everybody. All right, there's your table of contents. Go ahead and write it down and come on back when you're done. Okay, we're going to be covering triangles in this unit. Triangle is a three-sided polygon, and notice we have a new symbol. So it actually is a little triangle, so make sure you can make a note of that. Just like we had symbols for angles, we have a symbol for perpendicular, we have a symbol for parallel, we now have a new symbol for triangle. All right, naming triangles, you simply use the letters at the corners of the given triangle. So when we were talking about angles in the last couple of units, the way we named the angle was actually really important. So if I had angle ABC, I could say angle A, B, C, so angle ABC. Or I could say angle CBA. But the important thing was when I was naming the angles that the vertex had to be in the middle position of the angle naming process. Not so true when you're talking about triangles because it's a closed image. Notice how your angle is open on one end, so my angle is open on this end, where my triangle is completely closed in. So when I'm naming my triangles, the order of the letters really doesn't matter. For example, I could call this triangle AXM. I could also call it triangle AMX. So I can go in either order. I can go clockwise or counterclockwise. And I don't have to start with A either. I can start with X. I could label it XMA, so I could call it triangle XMA. Or I could go the backwards and name it XAM. So it doesn't really matter with the order. The one time it will make a difference when we're talking about ordering or naming triangles is when in the future down the line, we're going to be comparing two triangles. So say I have a similar triangle to this guy. I'm going to try and draw a similar one to this big blue one here. It's not going to be exact, but I hope you get the idea. So I'm going to call this triangle BCD. So if I'm going to name the triangles, or call them similar triangles, which is what we'll be doing in the units to come, if I'm going to name this triangle AXM, so triangle AXM, and I want to say that's congruent to the other triangle, I have to go in the same order. So since I started with A on this one, I have to start with the same position on the other one. So that's going to be triangle B. So I went A to X, and then to M, so I'm going to go B to C, and then to D. So B, C, D. So in that instance, oops, I forgot my little triangle symbol. In that instance, the order will matter when you're naming your triangles. But if you're just talking about a single triangle, the order does not matter. All right, this is really important. This is a main takeaway from algebra. We're using this for the rest of the year. The sum of the angles of a triangle is 180 degrees. So make sure you get the image and the little equation in your notes. Little practice examples for the last slide. Sum of the angles of a triangle is 180. So if I have two known angles, which I do here, I know this angle is 82 and this angle is 55, I can simply subtract my angles from 180 to find the missing angle. So 180, let's add up 82 and 55, that's going to give me 137. So I have 180 minus 137, so that missing angle is 43 degrees. That's where the 137 came from. I added those two together. So over here, I'm going to do 180 minus 36 minus 57. So again, it's easier for me, if you want to just put this whole thing in your calculator, I'm totally fine with that. It's easier for me to add these two together first. So that is going to give me 93. That's a total of 93, which means this one has to be 180 minus 93, which is going to give me 87 degrees. All right, classifying triangles. Equilateral, equiangular, means it has 3 equal sides and 3 equal angles. Also important to note that the angles of an equilateral triangle are always going to be 60 degrees. The reason that is if all of the angles have to be 180, and equiangular means all the angles have to be equal to each other. If I divide 180 by 3, that gives me my 60 degrees. So it's a very special triangle, has equal sides and equal angles. Also, I would like to mention we have a converse situation going on here. Last unit we talked about converses, how if we make one statement, we can flip it around and make another statement that may also be true. If a triangle, in this case, if a triangle is equilateral, then it is equiangular. So if the sides are all equal, then the angles are all equal. And you can also say the converse of that. If the angles are all equal, then the sides are all equal. So in this particular case with equilateral, equiangular, we have converse statements that we can make about those triangles. Isosceles triangle has 2 equal sides and 2 equal angles. So we do have 2 types of isosceles triangles. Notice the markings here. So that means the sides are equal. And then, of course, this means the angles are equal. Also important to note that the angles opposite the sides are going to be the equal angles. So that's kind of important to know also. We have an acute isosceles in which all of the angles are less than 90. And then we also have an obtuse isosceles where one angle in this case, this angle is greater than 90. We had a conversation in class about why are these marked with 2 arcs instead of just 1, like this guy over here. Honestly, it doesn't matter how you mark something congruent as long as you mark it the same way. Okay, so for example, if I know that these 2 sides are congruent like they are marked here, if I want to, I could mark them with a smiley face. All right, so it doesn't really matter how you mark them as long as you mark them the same. You wouldn't typically see things marked with a smiley face, but if that's the way you would like to mark it, then you're free to do that on your own. All right, I have scalene triangles, which have no equal sides and no equal angles. So let's go back up the truck a little bit. First, we talked about equilateral that had 3 equal sides and 3 equal angles. Then we talked about isosceles that had 2 equal sides and 2 equal angles. Now we have the scalene triangles that have nothing's the same. No equal sides, no equal angles. So there's 3 different types of scalene triangles. We have the acute scalene, which of course all angles are going to be less than 90. And then we have the right scalene where one of the angles is a 90-degree angle. And then of course we have the obtuse scalene where one angle is greater than 90. So this angle right here is greater than 90. But the other 2 angles will have to be acute angles because, as you know, the sum of the angles has to be 180. So whatever these 2 are, whatever this one and this one is, are going to have to add up to 90. So they both have to be acute. All right, see if you can figure out what kind of image this is. Look at your notes. If you guessed isosceles, you are right. It has 3 equal sides and 3 equal angles. All right, looking at your notes, see if you can figure out what this one is. If you guessed isosceles, you are correct. And then finally, this last guy over here has different markings for every side and different markings for every angle. So that means it's acute. It's a scalene triangle. Nothing is the same. And in this case, it's actually an obtuse scalene triangle because this angle looks larger than 90 degrees. All right, we have a right triangle. So go ahead, and you're pretty familiar with right triangles. The only thing we have not talked about before is the right isosceles triangle. So right isosceles has 2 congruent sides. And then because these 2 angles have to add up to 90, because this one's already hogging up 90 out of 180, so 90 is going to be left. So here's what I'm talking about. 180 minus 90 gives me 90. Okay, so I took this 90 degrees out of the process. So that means this angle right here plus this angle right there have to be the remaining 90. But since this is isosceles, they have to be equal to each other. So 90 divided by 2 gives you those 45-degree angles. All right, parts of a right triangle. I need you to have this diagram copied down in your notes. Also important to note that the hypotenuse of a right triangle is always opposite the right angle. All right, let's verify each triangle. I'm going to call this isosceles because I have 2 congruent sides, 10 and 10. In fact, I'm going to call it an isosceles right triangle because it has that right angle there. I'm going to call that an equilateral because all sides are congruent. By the way, this 25 indicates the side length. All right, you know that if it was an angle measure, for example, if this was an angle measure, you would see a little degree marking on there. So that's the difference between knowing whether it's a side length or if it's an angle measure. So if it's 40, since this is equilateral, I shouldn't have put 40. This is 60, this is 60, and this is 60 because it's equilateral. All right, let's skip that. Okay, what are the measures of each of the angles in the triangle? When you're doing these little geometry puzzles like this, where and they are puzzles, You want to look for a triangle where you have two known angle measures, or at least where you can figure one of them out if it's missing. So you need at least two to find the missing angle. So I can see that in this triangle over here on the right, this guy right here, that I know this angle measure is 90, and I know this angle measure is 40. So if I add those together, I get 90 plus 40 is 130. Which means that my missing angle has to be 50 degrees. All right, so if this guy is 50, I can determine what this guy is because these are that special vertical angle relationship that we already learned about. So if this one's 50, this one also has to be 50. And then now look what happened. Now I have an angle here and an angle here. Those are going to add up to 145. Which means this one is going to be 35, because when I subtract 145 from 180, that gives me 35. All right, here comes the algebra. So same situation applies. They still have to add up to 180. So if you want, you could write out this big long equation, x minus 44 plus 2x minus 72 plus x equals 180. You're welcome to do that if you want. I would rather take the shortcut method, which I can combine my like terms just from this drawing. For example, I have 2x plus another x plus another x. That gives me 4x. And then I'm going to combine my numbers, negative 72 and negative 44. That's going to give me negative 116 equals 180. So notice if I would have done that up here, I have x plus 2x plus x. I still get my 4x that I have here. And then subtracting 144 and minus 72 is still going to be the same thing I did right here. All right, so adding 116 to both sides is going to give me 4x equals 296. And then when I divide both sides by 4, that is going to give me 70. Let's do 296 divided by 4 real quick. 74. And then, of course, you could take this value and plug it in. This angle would be 74. This angle right here would give me 74 minus 44, which would be 30. And then I could add these two together, this 30 and 74, that's going to give me 104. And then if I subtract that from 180, that's going to give me, this angle is 86. So when I plug 74 in here, I should get 86. 76. Because 76 plus 104 is 180. All right, on your own, try that one. All right, so I got 8x minus 4 equals 180. 8x equals 184. And then when I divide both sides by 8, what's going on with my pen here? When I divide both sides by 8, 16, 24, that's going to give me 23. Okay, and then you can plug it in and find the other angles. All right, summing it up, what do we know about three angles in any triangle? We know that they add up to 180, but there's something else that I want you to take away from this, and that is this. What is a conjecture we can make about all four angles in a quadrilateral? So a quadrilateral has four sides. That quad means four. So a quadrilateral is a square, it can be a rectangle, it can be a parallelogram, it can be a rhombus. Okay? For the square and a rectangle, it's really easy to determine that I could figure out that the angle sum has to be 360 degrees, because each one has four 90-degree angles. But what about these two guys? Well, as it turns out, here's something you can think of. I can cut a diagonal line through that cuts that parallelogram in half. I could also do that with the rhombus, where it just cuts it into two different triangles. Well, we know that each triangle has 180 degrees, so if this one has 180, and this one also has 180, then that figure will have 360 degrees. So all quadrilaterals, all four-sided figures have an angle measure of a total of 360 degrees. Okay, homework 4.1 is due tomorrow, and hope to see you then. Have a good day.